Hi, I'm Sarah. In the past few videos, I've been going over UX concepts and the little extra steps that we can take to build great user experiences. Today, I'm going to go over one more important concept, and that's error handling. So far, we've covered search field optimizations and animations for long-running API calls. But what happens when something goes wrong? The same concepts apply here. We need to make sure that our apps are responsive, easy to navigate and understand, and provide a seamless user experience, especially when there's an error. How can we accomplish this? First, we need to provide useful error messages. This means avoiding generic messages like something went wrong, or search error, or network error. Second, we should try to give the user the option to easily try again with a minimal amount of taps. The goal here is to limit user frustration as much as possible. Here are some examples that I've built into my project. I'm continuing to demonstrate the food tracker app that I've been developing in this series. Because the Open Food Facts database is enormous and loaded with tons of hits per day, sometimes the API calls time out. In OK HTTP, I have the timeout set to 120 seconds. After that, an error will occur. When this happens, first, the loading screen icons animate to a grayscale color matrix, so the user is instantly notified visually that there's been an error. Second, I let the user know that the search is timed out and suggest that they might want to try a more specific search. Finally, I give them the option to easily try their search again and change the search terms if they want to. This is great because now they don't even have to bother hitting the back button and starting all over again. And if they want to search again, they could easily search for crunchy peanut butter instead. Here's another scenario. Let's say that the user has forgotten to connect to the internet, or something is wrong with their Wi-Fi or data service. For this screen, again, the icons animate to a grayscale color matrix. Second, I let the user know that the problem might be their internet connection. Once they fix it, I give them the option to try their search again. Continuing with the unreliable Wi-Fi or data connection scenario, there could also be an instance where the first page comes back just fine, but while the user is scrolling, they lose their internet connection. Here, the error message displays below the last successfully loaded product. Again, I'm letting the user know that it could be their internet. Once they're reconnected, they can easily tap the card to try again. If they've reconnected successfully, paging 3 will go ahead and get the next page. The error message switches to a shimmer as the products load, and they're appended below the initial product list. Here, the user didn't need to click back or start their search all over again. This is a great feature of paging 3, and I'll show you how this works once we get into the code. Finally, for my app, I had to handle errors on the product detail screen. A couple of things could happen here. First, the product simply might not exist in the food database. Or, if the barcode was wrinkly or scanned in low lighting, it could be misread. There could also be the same errors that I demonstrated for the search screen, including connection timeouts and internet issues. Here's how I handle errors on my product details screen. The barcode will always be listed in the top app bar, whether the product detail page was accessed from the search results or from a barcode scan. Below the top app bar, I let the user know that the product wasn't found. Next, I provide the same types of errors that we saw for the search screens. In this example, the user scanned a barcode, but their internet wasn't connected. The first message gives the user the option to try the API call again once they've reconnected. The second message provides some help for scanning barcodes and lets the user know what barcode came back from the scanner so they can verify it with the product that they've scanned. And that's a quick overview of how errors are presented to users in my new app and the different scenarios that they might encounter. Now, let's dive into the code and see how all of this works. Following good app architecture patterns, we might find ourselves hitting our repository from our view model, then pushing errors to the UI with state flows. Things are a bit different with paging 3. Most of the errors originate from loading state errors that we have access to from our composables. Because of this, I'll start by going over my paging source class and explain how I push my custom error messages to the front end. With Hilt, my product search paging source takes in my food API, which is just a retrofit interface, and the product that a user is searching for. So I've got the food API here, the search text here. Next, I override the load function and set it up to return my search product item. Before I show you that data class, now is a good time to show you how the data comes back from the API. In my data layer, under the remote package, I have a mock folder that I use for displaying previews. Let's go to the search results mock and check it out. Here's a real JSON response that comes back for corn chips. The API returns the total product count, current page, page count, which is how many products are on this specific page, and then the page size, the max products that are returned per page. Then I get a list of products which are stored in search product item. For paging 3, I use this metadata to determine my paging functionality and the search product item as the load result. So let's take a look at this real quick. So we've got the count, which is the total count of the products. We've got the current page, which is 1. The products per this page, so there's 24, and the page size is 24. And then we get a list of products. So I'm getting back the brand owner, which is Walmart stores, the code, which is the product barcode, the image URL, and then finally the product name. And these products are all stored in search product item, which is just a data class. So we can see we've got the code, the brands, the image URL, and the product name. Let's go back to product search paging source and see how all of this comes together. So here, where I'm overriding the load function, we've got the load result and the search product item, which is that data class that contains the product. So we've got the code, the brand, and the product name, and the image URL. And the first thing I do is get the current page, and if it's null, then I set it to 1. Now, it's time to hit the API and set up the paging logic. I wrap the API response in a sealed service result class that returns a service result success or a service result error. Let's take a look at the error class, because this is key to returning the custom error messages to the user front end. This class returns an error code, which contains a specific error message depending on the API exception type. And let's look at these error codes. This enum handles all of the error types. So we've got an API search timeout, a product search timeout, network errors, and the product not found. And then finally, I do have a generic API error, just in case we can't figure it out, and we do need to show a generic message to the user. Sometimes that's okay if there's no other way to determine what the problem was. Now that we've taken a look at the error codes, let's go back to the paging source. I call the API here and get search results. This function takes in the search text and the current page, which starts off with 1 for the initial fetch. I hit my API, passing in the search text, current page, and specific fields that I'd like to return instead of all of the product fields. This keeps my response light, fast, and efficient. To do this, I have a companion object on my search product item. Let's take a look at this real quick. So here's that data class that returns the products, and this is just basic setup and a serializable data class. And down here, I have a list of fields that I want. That way, when I call the API, I just join them to a string with comma-separated values. So in this companion object, I have fields, and then it's a list of code, brands, image URL, and product name. And then to call that, I just call it search product item.fields, joined to string. If my API call comes back with an error, I check for socket timeout exception if the search timed out, I/O exception if something went wrong when we tried to connect to the server. And finally, I trap all other errors like HTTP error codes in a more generic block. Now, let's go back to our load function. Okay, so the API call was a success here, and now we need to define a previous page and a next page before we can return the data. To avoid unnecessary API calls that return an empty, non-existent page, we should also see if we're currently on the last page, if possible. Luckily, with the API that I'm using, I can get all of this from my JSON response. There are a few ways to check if I'm on the last page, but I went for multiplying the current page by the page size. So if I'm on page 5 times 24 products per page, that's 120. If that number is greater than or equal to the total product count for this search, then I'm on the last page. So here's my calculation here. And then here I set the previous key, and if the current page equals 1, it's null. Otherwise, it's the current page minus 1. And the next key, if we're on the last page, make it null so we don't make that extra API hit. Otherwise, it's the current page plus 1. Now, if there was an error, here I return loadResult.error and pass in the custom error code message that we check for in the API call. Later, we'll check for this error message from our composable. So if it's an error, go ahead and turn this throwable and get the results.error.message, which is going to be that enum that we looked at before. In my repository, all I need to do is return the flow of either a loadResult.page or loadResult.error from my paging source load function. You do this by configuring a pager instance. Here are some notes about paging config. I already know that I have 24 items per page. The API has done this for me on the server. Out of the 24, about 5 products are visible on the screen at a time. When you set page size, the prefetched distance and initial load size parameters are then derived from this value by default. At first, I set my page size to 24. This resulted in paging 3 returning 2 pages for my initial fetch before the user ever saw any results. Because the API that I'm working with takes a few seconds to come back, this wasn't optimal for my user experience. At the same time, though, I didn't want users to see a bunch of loading more record shimmers while they scrolled through the results either. By setting my page size to 24 and my prefetch distance to 12, now I get 1 page on my initial fetch, and paging 3 gets the next page after I scroll past the 7th product. This seems to be a good balance for my app. By default, my max size is set to max size unbounded, which means that no pages are dropped in memory. So far, this seems to be working well. I haven't had a crash yet. For me, the docs for paging config are a little confusing. I encourage you to look at each of these settings and play around. Writing out debug info to Logcat definitely helps in situations like this. If your API is fast, setting the page size alone might be just fine for your app. Now, in my search view model, I set up a mutable state flow to store the flow from my repository. So here we have search results, and it's a mutable state flow of paging data, and it's the search product item, and by default, it's paging data.empty. In my init function, I call getProducts. So let's go down here. I set the state flow in this function and cache it in the view model scope. So if you're familiar with paging 3, you've seen this before. I'm calling my repository. I pass in the search text and I cache it in my view model scoped. And then I call collect. And then I just set that mutable state flow that I declared earlier to the result that comes back. Now I'm in the search route, which takes in the view model. This route gets the search results from the view model and then collects them as lazy paging items. So it collects them here. Then I pass these results to the search results screen, which handles all of the possible paging states. You might be wondering why I pass in the load states separately. This is so I can pass whatever states that I want to in my previews and see how my composables look with the different paging states. So this composable here gets in the search results, and then the load state for refresh, and the load state for append. So let's go down and look at this. There are 5 key states to consider here. Is the first fetch loading? Does the first fetch have an error? Is the first fetch complete? Are we getting the next page? And finally, was there an error getting the next page? That's a lot to check, but really, in code, it's not so bad. What's also nice is that since the search results are cached in the view model, I don't have to worry too much about variables and recompositions here. Everything seems to work really well when I rotate the phone without having to remember anything here. First, I see if I need to show the loading screen by checking the refresh load state. Next, I check to see if there's an initial loading error. This message is coming from loadResult.error throwable that we saw earlier in the paging source class. And here, I checked to see if we got an error when I tried to get to the next page. Again, this is coming from paging source. This block here animates the content between the search loading screen and the search results list. I've already gone over this in my previous video, so I'll skip it here. If the initial search results are still loading, I pass the error message variable to the search loading screen, even if it's null. Let's see how the search loading screen handles the error message. The search loading screen shows animations if everything is going well, or the error message if there's a problem with the API. Okay, let's go down here and take a look. If there's an error, the header message is updated to try again. The animated icons also need to know if there's an error. If there is, then the icons will do a color shift to black and white. So here I'm calling animated search row, and I'm passing in whether or not the error message is null. If there's no error, then I show the loading shimmer. So everything's going good here. Otherwise, it displays the enum error code message that we got from the paging source. So here's the text with our initial load error message that's coming from the paging source. That's it for the search loading screen. Now let's go back to the search screen and take a look at the rest of the code. The lazy column loads if the initial fetch is complete and there is no error, but at this point we still need to be aware of 3 different states. If everything is going well, I show the list of our 24 products from the API. So here's the items and here's the search results, and then it shows the composable to show the actual product card. At the end of the list, show a loading shimmer if we need to load more. This means that they'll see getting more products if paging 3 is fetching more pages from the API. And finally, check to see if we got an error when requesting additional pages. One really cool thing about paging 3 is that if we did get an error here, there's no need to start over at page 1 again. Here, I use searchResults.retry to request the page that failed again. Let's take a look at this composable real quick and see how it works. At the end of the original results, this gray card appears if there's an error. The whole thing is clickable, so users can just tap, and paging 3 will try again based on the current paging key. Here I just set up my composable. It's a gray elevated card with a little bit of transparency. And then down here, we show the error message and it says tap to try again. Now that we've gone over the different states, let's try to get a preview of what each of them looks like on the search screens. Here I'm using the preview parameter annotation to loop through all of my paging states. Let's go into search results feature and see how this preview data class is used. So I'll go into my search results feature, and this is just a data class that holds the search results and then the refresh load state as well as the append load state. Here, I manually decode the search results into a search results data class using the search results mock JSON that we saw earlier. Now, with the preview parameter provider, I can set up all of the paging states that I need to track along with the corresponding error code messages. Here, when I override the values, I create a sequence of different states for the app. So I've got the search results, I've got load state loading, and load state not loading for the append. Here, I actually throw an error and pass in my custom error message. And here I pass in the API search timeout error message. And then as you can see, I just go through each state and I can set them up specifically. Now if we go back to the preview, we can loop through each of these states and easily see what each of them are going to look like. So let's go ahead and take a look. In the first preview, we're waiting for our search results. So here, everything is going well. In the second, we've got a network error for the initial fetch. So here, with the preview parameter provider, I can specify the network error message. We can see that our icons have animated to gray, and the correct error message is showing here. The third preview shows the connection timeout error for the initial fetch. Again, we can see the gray icons and the correct error message. And finally, we can see the error message that we'll get if we're scrolling through the list and something goes wrong when we try to fetch the next page. Noticed in the last two previews, we only get the error, but actually if I use the interactive mode, then I can see how this will look on the front end. So let me go ahead and show you what that looks like here. So here we go, our results load up and I can scroll through and then I see my error down below. So this is pretty cool stuff. Again, that's the power of previews and preview parameter providers. That covers error handling for the search screen. Next, let's take a look at the product detail screen. For product details, again, I'll start with the data layer and work my way up to the UI. To get the product information, I send a request to the API with the product's barcode in the path. I don't check for HTTP status codes in the search results just yet, but here, it's really important that I check for a 404 not found. Besides that, the error handling is very similar to what we saw in the search results handler. So here I just go down, I start a flow, I admit that I'm loading, I call the API, and again, I'm checking for a socket timeout, an IO exception, and then here's where I check for the HTTP exception. So if it's 404, then the product's not found. And otherwise, if none of these match, then I just emit my generic error message. And just notice that the error messages are a little bit different for the product than they were for the search results. In my product detail view model, first I get the barcode as a state flow from the save state handle. This comes from either the search results or from a barcode scan on the home page. If the product isn't found when a user scans a barcode from the home screen, I'm also giving the users the option to scan it again. This means that I also need to track the barcode from my barcode scanner service, and that the barcode from the initial save state handle could actually change. So here, I'm getting the flow from the save state handle, and then here I get a separate flow from my barcode scanner service. Then, I use flatten merge to get a single flow from both of my barcode flows. When the view model loads, first I'll get the barcode from the save state handle. After that, the flow returns barcodes that are emitted from my barcode scanner service. Using on each, every time a barcode is read, the flow automatically initiates a call to the API to get the product detail information. This way, I don't need to have an init function in my view model. So here I'm just merging these flows together and combining them into a single flow. Then I set up some other flows and I combine them all to create my state for my composable. In Get Product Detail, here I just check to see if my service result wrapper returns an error code. If it does, I update product error, which is collected in my composable. Since I use flatten merge and combine in my view model, here I can always be sure that my barcode is current and that the product that's loaded in item listing matches the barcode that came back from the flow. So here I set up my key variables and I get them from the product state that's set up in the view model. And then I call my item detail screen. So let's go down to that real quick. If the product error message isn't null, it's passed to my product image composable. And I'll go into that and show you what it looks like. Let's not look at these just yet. So here I set up my composable. Again, it's an elevated card, and I animate between the loading and not loading states. If the product isn't loading and it's null, then I know that I have a problem. Now it's time to figure out what to show the user. First, I set up the barcode message. If the error message from the API isn't null, then here I include it in this composable. If we got to the product details from the home screen, this means that a user scanned a barcode. If that's the case, then I also show the barcode error message. So here I check to make sure that we've come from home. And if we do, again, I call this composable and I pass in the correct error message and what to do if the user needs to retry. In this composable, the entire card is clickable. It displays the error message to the user and allows them to try again. With preview parameters, I can loop through each scenario and see what it looks like. So again, I've created some preview parameters and I've set up the different variables that the state can hold. So we can hold the product, whether or not it's loading, the from screen, the error message, and the barcode. And again, I decode the JSON. Here in my preview parameter provider, I can provide both successful states and error states, and I can specify whether they came from the search screen or the home screen, and I can also provide the different error messages that come back from the API. So let's go back and see what these previews look like for each state. Here in the first preview, the product is still loading. In the second preview, the product has successfully loaded and we have the product name up top. Now here's the error handling. So we can see that it's taking longer than expected. So this is a connection timeout. The next preview shows an I/O error. And then finally, in the last two previews, it shows that a barcode was scanned and provides the different options and error messages that might have come back from the API. Handling errors gracefully and responsively is key to creating a great user experience. A simple snack bar might work in some cases, but if you need more functionality, don't hesitate to go the extra mile. Your users will appreciate it. That's all I have for today, and thanks for watching.